This is a recording to help out with lab number 4 in CIT250. So to get started, go into section 1, lesson 2, and click on lab 4. Alright, so the whole purpose of this lab is just to go over some very basic encryption to tackle some very, both a simple cipher and a complex cipher. By doing this, we can talk about some bigger picture items like the power of repetition, the power of variation. So let's get started, or let's get cracking. All right, so here's a simple, so the very beginning of the lab says here's a simple substitution cipher text. And so what we're going to do is we're going to copy that. And perhaps I should make this a little bit bigger. There we go. And we'll make this go away. All right. So I copy that. And so we're going to need some help. Obviously, this is a simple substitution, but nonetheless, help is a good thing. So we're going to use our tools in this website called the Black Chamber. So what we're going to do is it's a simple cipher text. So our simple substitution tool. So what we're going to do is we're going to click this and put it into the cipher text. And we're going to try to make some plain text out of this. All right. And, we're going to use the basic techniques that you use when you do crossword puzzles or you solve many different kinds of riddles. So, but we also have tools. So if we click on frequency of individual letters, and I'll make this a little bit bigger. We see, for example, let's pick on a letter. Well, this is really curious right here. Let's start off with, we got 2 R's in a row. All right. Let's look at the letter R. Normally we would expect, so this is what the frequency in the cipher text. So in this case, we see R 14% of the time. Normally we would expect to see it at 6%. All right, that's quite interesting. So let's take a look at some of the possibilities. Now, interestingly, because it's a repeated letter, and we can click on this other tool. And what this other tool says, there's a pattern, right? So again, we're deciphering English, and English, like any language, has a series of rules. In English, the most common repeated letters are SS, EE, TT, FF, LL, MMOO. Since we're in the middle of the word, it would be odd if it was a repeated consonant. So we're looking at either EE or OO. All right. So if we look around at some other R's, like we got something here that's blank R or JR over here, and some more J's. That's interesting on either side here. That's something else we want to look at. Here's an R in the middle. I think there's another R somewhere. Here's a R in the middle here. But anyway, so we see this character sprinkled about, and so now we have to figure out whether or not we think this is going to be EE or OO. Now, if you go completely on frequency, you have a very good reason to believe it should be EE. E is normally 13%, and R is quite prevalent in this cipher. Now, again, part of this is the data we're encrypting. We had a grand total of 98 letters, so keep in mind that the bigger the text, the bigger the amount of data being ciphered, the greater chance we will have normalization of these statistics, right? So we're looking at the letter R, and let's just go with E off the top of our heads. So we're going to take the letter R and we're going to make it an E. All right. So I hit the wrong button. There we go. So now we have lots of E's. All right. So how many letters? We have a couple character. Well, and this is getting weird, right? We have this JR twice. Me, he. There's a couple possibilities there. And then this is really odd. An E blank word. It's giving me doubts at this moment. We might just have a statistical anomaly where the O, or where there's a lot more O's in this phrase than there normally is. And again, it comes down to this E star, right? That's off the top of my head, other than the Latin et. And again, I'm trying to do nothing but English here. I can't think of anything that would be E something. I guess you have ET like a name. So let's switch this back to an O now that we've seen it. All right. And if that becomes an O, we have ON is the obvious one, on. OF is also a possibility. So let's take a look. What letter is that? That is going to be the letter D. Okay. And so would D, based off frequency, make more sense to be an F or a N? So we see D about 5%. N we would normally see about 7%. And F we'd only see about 1% or 2% of the time. So let's go with N. And that might make a lot of sense because we have one up here. Well, let me see. We have another one right. Was that that was a J? No. Right here. It's a D. So we have another D over here, obviously, but we have a D right here, DRA. So as compared to making it to be 4. So anyway, let's not overanalyze. Let's take some stabs here and hope we got it right. So here's our. So we're going to do the D equals N. All right. So let's pick on another. See if we see another 2-letter word. So we have this other 2-letter word. No would make sense. However, 2 makes a little bit more sense. Let's look at the letter J and see the frequency of J. Whoa, there's a lot of J's in here, which kind of lines up with T. So we're going to go with J equals T. All right. We got on to. That would make sense as this being the. So again, let's confirm with our numbers. K being H. So K we see 6%. H would be 6%. This is looking pretty good. So let's go with K being H. And on to the. So I'm guessing this is next. That is also. Oh, we already have H. So this could be interesting. You have 2 different letters with T on either side. So, oh, yeah, okay. Now I know what that probably is. 2. Here's another 2-letter word that kind of popped up on us. We have a B and a W. If we see any more W's, we see a couple. Let's take a look at the frequency of the letter W. Oh, we think W is definitely E, right? Because we have on to the, right? And actually we have a W on this. Let's just put that in there and see what happens. Well, we should confirm. So let's go click on this. Let's see how often W's. Whoa, there's 16% W's, which would be close to, because we have 98 characters, which is close to saying 16 W's. And the letter E, we would expect to see 13. So let's go with that. W equals E. So you can see it populates automatically onto the, right? and this is 2. B would be an interesting one. B would equal B. That's a fun one. We have another B up here. Let's take a look. B was 3 to 2%. So let's do it. Let's make that B, and then we got ob. So we'll keep an eye on that. So we already did T. Oh, well, there you go. I think we have an X there. So U, I think, is X. So we have on to the next. And then we have text up here. So to be, so this can't be not, because we're happy with T's, I think. So let's go with A as W. Let's see if that makes sense. A will only see 1%. W, you'd see about 2%. So that does make sense. So let's do a W here. It's only filled that one in. So so this ob pops up at me, right? So job would make sense. How many M's are there? There's only one M, and J isn't all that popular of a language of a letter. So let's put that in. Let's make M of J. There's no other repeat characters on this, so all right, so we're thinking this is now move on. So let's do C equals M and H equals V. Let's see if this makes sense. There we go. And we got either hive or have. I'm going to go with hive, and I can really confirm that because A normally is 8%. I, well, there you go, though. I is only 3%. So we're kind of going out on a limb here, but I'm pretty convinced this is going to be a have. So we'll make that A. Have, so anyway, you should get the idea at this point how this game is played, if you will. Again, you want to attack the smaller letters, right? You're looking for patterns. Use the frequency of repeated letters as a tool. There's others as well. There's frequency of pairs of letters, and they explain it in here. But what it comes down to is vowels tend to, in this case, I've got this thing a little too zoomed in. So vowel pairs often line up. So in this case, J was a vowel, right? So we're looking for patterns. K and W, I think we were said K and W were, well, that's a H, O, and E, right? So usually you can use that to see. There's the vowel trowel. You can actually go through and try to figure out which ones are vowels based off frequency of use. And you can clear all the boxes and start all over from scratch. Hopefully you don't have to do that. So I think I'm going to leave you with this one, with the two substitutions. We have a substitution here, and here's another substitution with more characters. All right. So I'm going to leave you with that to do. Let's talk about the Vignette Code, which I may or may not be pronouncing correctly, but I'm going to keep it going. So this is a big block of data. As you notice, there's no spaces. That's not fun. So we're not going to be able to just brute force this. So the Vignette Code was a rather famous cipher used in starting the Renaissance in Europe. This Alberti invented this system. Now, primarily, it's built on two things. Number one is the key. All right, we can do this. So there's the building of a square. As you see in the square, it's just A through Z, and then B through Z, then starting with A. So we just keep moving over one position over. And that's why you got these W's and these M's, and the M's over here kind of just swinging through and rotating, right? Because we're just keep rotating by one letter. And we create this table. Now the way you do it is this. So you pick a keyword, and this is going to be key, right? So you then take the keyword, you smash all these letters together, and you repeat the keyword until it completely covers the plain text. So if I do that, here we go, white, 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 and it goes all the way to starts beginning white, but it ends, right? The message we're encrypting is divert troops to East Ridge. So the way this works is this. I compare the keyword to the plain text, which is a WD, and then I just play battleship. So I have a W here, and I bring it down. Let's see if I can make this a little bit bigger to make my life easier, or is that just a picture? I did nothing but confuse the situation. That is correct. All right, so I have a W, and I'm going to try to hit the D right here. So by my I, it looks like we should have a Z. So I'm going to hit letter cipher, and we get a Z. Next one, H to I. I'm only going to do another one, so don't fast forward just yet. H goes to an I here. By the way it lines up, it looks to me like it should be a P, ZP. So I could just go through and, following that process, encrypt this. So reverse engineering this is a very difficult thing to do because you have multiple stages. A, you have a keyword you don't know, and B, you're hitting the letters here and you're throwing another variable in. So how do we crack this? Well, it was Charles Babbage who finally broke it in around the mid-19th century. And it comes down to pattern recognition, but also brute forcing it. All right. So it comes down to this. There's going to be a repetition, right? And this is, again, goes back to our lesson about the power or the dangers of repetition when you're encrypting. So with repetition, we can see patterns. So let me put in my cipher. I'm going to do a Control A and Control V. All right, and there's the cipher I have part of our app, our lab. So I then click this button that says find repeated sequences, and what it's going to look for is 3-letter sequences. Right now, what that 3-letter sequence tells it is there becomes only certain key numbers make sense for that to work. This sequence, based off the spacing and when it's repeated. And so, like in this case, HVQ, the spacing seems to be 637. That would only work with a key of this a length of 7 or of 13. If we go down to CGI, we have, and with a spacing of 366, it would work with a 2-letter key, a 3, a 4, a 6, not a 7 and an 8. Sorry, I think no, I'm missing. All right, so I'm sorry. It's 2, 3, 6, and that's it, right? So there's no perfect answer. There's no everyone gets a massive hit. It's like a shot chart, right? It's kind of like a birdshot chart, right? But it's where you get the most hits. In this case, I think a pattern is developing here that 7 is the magic number. So if I click on the 7, I go down below, I get my 7-letter key, and I can start guessing, right? Now, how am I going to start guessing? Well, if I click on the letter, we can use pattern recognition. Again, going back to this normal English versus what this would make it, right? So if this letter of the key was this, and because we can know the actual cipher, we can reverse engineer it and say if the first letter was A, these would be our results. And if these are our results, this is the pattern. Again, the amount of data you encrypt is big because you're normalizing the odds number as well. So the amount of data you encrypt helps it easier to guess, and the size of the key matters a lot too. We might see that a little bit later, right? If you have the bigger the key, the more effective and the harder it's going to be to predict this pattern. Okay, So back to this letter. What we do is we clicked A. This is clearly out of sorts. We have a huge hit on Z when we shouldn't have a hit at all. And I do like to focus on Z. I try to look for something where you have a couple, 2, 3 in a row that aren't a lot of hits, and right next to it is something that's an A, or that would hit the A. So let's, oops, I hit the wrong button. Let's go this way and see. This kind of makes sense, but there's a lot of Y. This is, you know, the G isn't lining up the way I'd hope it would. So if we keep going, and here's the problem, by the way, you can only rotate till you get to N, and I don't want to rotate that way. I'm going to try to line up this Z with my good friends over here. That looks pretty good. I got my A here, right? Ooh, look at E. E is building up nicely. We got a lot of O's, but they got to go somewhere, right? And a good amount of T's, but I can live with a good amount of T's. And this X and Y, and Y shows up a little bit, but just enough. So I'm going to stick with this. I'm going to hit this button now. And again, we're going to play this game where I'm going to try to line it up. And again, what I like to do is I like to find an area where the worst hit is right there. And I kind of like that. I like lining up that Z with the smallest hit. Now, in this case, the J also is getting a really small hit, and J is not really used all that much in language. In names it's used, but not language. So I like this pattern. It seems to match. So let's go with the next one. Again, I'm going to kind of focus in on this. There's that looks pretty good. That's a lot of Y, but let's give that a shot. Am I moving it the right way? No, I'm not moving it. I'm sorry. There we go. So that's a lot of A, but Z's looking good. That's a good amount of Y. Again, a lot of T's, but we're kind of seeing that. This pattern is developing that way. J's are low. I like that. So let's move on. And now we can start looking at keys. If I randomize the word, then obviously this would be very difficult to guess. But if this is a sensical as a word, then I can start looking ahead and trying to figure out what this word is using common sense. Let's swing this through again and put that at the Z position and see what happens. Move. That doesn't look good. What about J? Yeah, that's way too many J's. So let's keep going. I'm going to have to swing all the way around, I think. And that looks pretty good for X. Let's see here. That lines up with X. That's nice. A fair number of J's, a little concerning, but nothing too bad. It's not that high up. All in all, we have a pretty good pattern here. Info. Okay. Well, it's too short for mation. Let's keep going with pattern recognition. This one's going to be a little tricky because we have a bunch of small ones here. So let me see if I line this up. That's a lot of A's, but this kind of matches up. Let's check our friend J. And J is pretty dead. These two are popping up just right. That looks pretty good. I think we're going to have to click this button here and move on. I got info. Okay, well, I think we're starting to get a little closer to what we think the answer is. That's a lot of Y. J lining up. A pattern. E's popping up. Info. That makes sense to me to be infosec. Well, there you go. So if I go infosec, that kind of lines up again. We're lining up the J's. That's a fair number of J's, actually. A. This is what I get. Oh, by the way, I can look over here and I can see that word get changed around, right? So high pro, well, if I go on over, profile, data, breaches, and information security compromise. Well, there you go, though. That's your answer. So what I would do is click it, hit Control A, Control Copy. And this goes for the other one, too. Down in your answers, I should hit again. Down in your answers, make sure you paste it exactly. So this one would be right here for the first vignette. I hit Control V. That's going to just go on, and there you go, and you'd submit it. So there we have it. I have 2 answers for you. Or, well, I started off with number 2, and I gave a full demo in number 3. Hopefully that's enough tools for you to solve it. I will say, question number 4 I do is a multiple, or is extra credit. I give you 1 clue. I say I used an especially large key. As a matter of fact, I could show you what that's going to look like because I used a especially large key. And it's a small data set. You can see how much smaller it is than the data set we had up here. Those 2 factors are going to make it more difficult. So if I go back here, I hit Control A, I can hit Control V, I paste in the new one, I hit, whoops, that's not good, right? There's no clear hits, right? And again, there's less repeated patterns because there's less data. So you're going to have to guess on the, if we go with 2, I'm telling you, I used a big key, so that won't work right off the bat. 20 is pretty high up there. 10 is pretty good. 5 is that really a large key. It'd be smaller than the one before. So anyway, I'll leave that to you. I will also so there's a clue in the actual thing, especially because I used a large key. There's numbers here. So good luck. And also I'll give you another clue that it's a poem and the key is the author. So. All right, well, good luck, and I hope you have fun, and I hope you learn something. Take care.